This lesson is for Advanced Algebra, Lesson 8-7 on powers and roots with negative numbers. Basically what we're going to look at is how to simplify a power or a root question when the base number is a negative. Quick reminder for students that when you see a negative number in front of a letter, in front of a number, that doesn't necessarily mean that it's a negative number. You want to pay attention to whether or not there are parentheses around that number and the negative sign. So the way that we look at the one on the left here, this is actually the opposite of 8 to the fourth, which means, according to the order of operations, 8 to the fourth and then take the opposite of the answer. That's different from you taking negative 8 to the fourth. So it is important for students to assume that this is a negative 8 unless there are parentheses that attach the negative number to the number itself. So you can see that these two expressions are indeed not equal to each other because one is a negative and one is a positive. I also need to review with students what to do with negative exponents. So we're not necessarily just looking at negative bases right now, we're looking at a negative exponent. So to illustrate that, let's just look at some patterns here with a negative base. Keep in mind that we did negative exponents in Chapter 7, and we talked about how when you have a negative exponent, what it does is it flips the base over. So you end up doing a reciprocal when you're working with a negative exponent. So a negative exponent doesn't change the sign of the base, it just flips it over and turns it into a reciprocal. That looks kind of like a 6, so I'm going to change that so that it looks more like a b. So let's look at what happens when you have a negative base and you're raising to a power. Negative 8 to the 1 is simply negative 8. Negative 8 squared, since it's a negative 8, is going to be positive 64. But now when we do negative 8 to the 3, that's going to go back to being negative. Negative 8 to the 4 is going to be back to positive 4096. So if we take those same ideas now and switch those exponents to be negative, the numbers are still going to alternate back and forth, because when you have an odd power, you're going to get a negative result. When you have an even power, you're going to get a positive result. All that a negative exponent does to that is just flip them over. So now we're going to have 1 over negative 8, 1 over 64, 1 over negative 512, and 1 over 4096. So when you change to a negative exponent, it doesn't affect the base's sign, it just affects where the base goes. So let's summarize that a little bit. When you're working with powers and the base is negative, an even power will produce a positive answer. When you're working with a negative base and you have an odd power, that will produce a negative answer. So here I kind of have it listed out in symbols as well. Negative base to an even gives you a positive result. Negative base to an odd power will give you a negative result. Students need to utilize their knowledge of exponents from the previous chapter as well as their knowledge here to solve questions, like the one here. Write as a single power, write without an exponent. Remember that when you have two numbers with the same base that are being raised to a power and being multiplied together, we end up adding the exponent. So in this case, the bases are the same, negative 6, so we're going to add the exponents together. So we're going to get 4 plus negative 5, which is negative 6 to the negative 1. A negative 1 power will take that base and flip it over. So that's going to be 1 over negative 6. I wrote it as a single power, and then I wrote it without an exponent at all. We're also going to talk about roots today, roots with a negative base. It's very important for students to remember to figure out the sign, meaning plus or minus, and to figure that out first before they find the actual numerical answer. Most of the time when kids don't do it first, they forget, and so that's my encouragement to you, is to figure it out first, write it down, and that way you won't forget it later. Similarly to what we just discussed with powers, when you have a negative base, you're either going to get a positive or a negative answer depending upon the type of exponent. The same thing is true for roots. When you have an odd root when you're taking the negative base, you're always going to be able to get an answer for those. Usually the answer will be negative. If you have an even root with a negative base, you can only find answers to square roots. Anything higher than that, like a 4th root or a 6th root or an 8th root, those are going to be undefined. And we'll do an example of why that is here momentarily. Be careful when you do the square roots of negatives. Remember that you're going to get an imaginary answer, sometimes also referred to as a non-real answer. For example, square root of negative 16. Normally we would not be able to do that, but remember we switched that negative 16 into 16 and negative 1. Square root of 16 turns into plus minus 4. Square root of negative 1 is I, so we are able to get an answer there. It's just an imaginary or non-real answer. So let's look at some specific examples in practice. So here we've got an even root, fourth root, of a negative number. So we'd be trying to find a number times itself 4 times that equals negative 32. If we chose a positive number, obviously we'd get a positive. If we chose a negative number, we would still get a positive. So on this one we would say it is undefined. There is no number times itself 4 times which would equal a negative anything. So this was an example of one of the undefined ones. Now you won't say undefined on number 2. The reason is we can rewrite this using our properties of powers as a negative 2, and then we raise it to the 8th power, and then we divide that power by the 8th root. So if we do 8 over 8, we end up getting negative 2 to the first, or just negative 2. So be careful, you won't necessarily always say undefined when the root isn't even, because sometimes you can use properties of powers to simplify in another way. Number 3 we can figure out because it's an odd root. Keep in mind that our answer will be negative. And so we're just trying to find a number times itself 5 times that equals 243. So I don't know, so I'm going to have to grab my baby calculator and do a little trial and error. I know I'm going to start with the number 3, and I'm going to figure out what 3 to the 5th is and see if that goes into 243 evenly. I know 2 to the 5th is not going to work because that's an even number. So when I do 3 to the 5th, I find out that that is indeed 243. So then that means that 3 is the 5th root of 243, and negative 3 will be the 5th root of negative 243. So negative 3 ends up being my answer. Got 2 more that I'd like to try with you. Number 4. It is an odd root, so I will be able to find an answer here. I know that I will have a negative result. And when I look at the 5th roots, I don't really know any of those by heart, so I'm going to write some of them down so that I've got those as a reference. So 2 to the 5th, that is 32. And 32 goes into 96. So right away I got my first result. So I know I'm going to get 96, or excuse me, 32, because I know that 32 times 3 is going to make a 96. So the 5th root of 32 I know is going to be a 2, and I know that that's going to be a negative number. And then the 5th root of 3 is left over under the radical. So that one I didn't know on my first try, but I guessed right away as 2 to the 5th. Figured that number out. 32 is a factor of this, so then I broke it up. The negative has to go with the number on the outside or the number in front. Anything left over stays under the radical. So that's the only new layer for kids that they have to worry about in this lesson, is that whenever you have a negative base, that negative should be pulled out. Last one we're going to do here is a cube root. As soon as you see a cube root and 3 zeros, that should be your hint that 1,000 is one of your options. So 1,000 times what is negative 2,000? That's got to be a 2. So I'm going to do cube root of negative 1,000, and I'm going to do cube root of 2. Cube root of negative 1,000 is going to be negative 10, because 10 times 10 times 10 is 1,000. And then cube root of 2 has to stay.